Mm. Great coffee. Hey, good morning. Russ here. Welcome back to the shop. I finally got it done. I got my little power unit. This is the Ryobi Battery Power Pack. It runs off of Ryobi batteries. You could make this using any battery out there, and you just would have to change the adapter for how this plugs in to whatever kind of battery you have. So you'd have to design that part. The rest of the components are I bought. You could buy those same components and do the same thing with any battery out there. Now, this, I kind of compare this mostly to the Ryobi battery pack units you can buy. There's two of them. One, you get two USB ports, but that's all you get. So you plug that in, then you can plug in your little devices like your phone and your cameras and that to recharge them. Or you can run a unit that runs off of a USB port for a very long time, but that's all it does. Then they also make the one, which is, I think there's now you can get it for about $65. Originally, it was over $100. And I still can buy it for over $100 if I look hard enough. But that unit has one electrical plug-in and a couple of USB ports, and that's it. You turn it on, you use it, you turn it off. And that's okay too. It's 150 watt capacity. So, you know, it's not bad. It's on the small side, but I wanted to make something comparable to do that because most of the time that's more than enough to run a lot of things that you want to run offline for whatever reason. Like charge, if you want to grab it, you can run a radio off of it. You can run and recharge your batteries on your computer, laptop, or your phones and things like that on the go while you're out and about. So it's still not a bad unit to have using a battery pack like of any kind. They're very handy things to have to be able to have that on the go. Especially the 110 is really nice to have on it. So if I compare this mostly to the Ryobi, because that's what really inspired me to make this little unit right here. Now, there is some advantages to this style unit over the Ryobi. Over the Jackery or the Rockpal. Those are based on the unit. The battery is actually self-contained in the unit. So you have to take the unit offline and plug it in to recharge it. You can't use it while it's charging. Whereas with this, you pull the battery out, throw another battery in, and you keep going. And you take these batteries and charge them up however you have to charge them up while you're still using this unit. That's a big, big plus to me. The other big plus about this, like over the Ryobi, is I have more than just the 110 and the USB port. Sometimes, believe it or not, there's a lot of things out there where you want to plug it in directly to a cigarette lighter type 12 volt into a type of adapter. So I added that 12 volt. Well, let me show you this unit and we'll see, and then we'll go over the changes. So this now, the battery would go into here, and you just plug it in, and you turn this knob a half a turn, and now it's made connection. And now I can read the voltage from the battery. These batteries, inherently, the Ryobi battery, fully charged is at 20.8 volts. When it gets down to 15 volts, it shuts off and no more power. Therefore, that's your range of battery that you can make use of on this. And the 5 amp hours, from what I understand, is in that range. So you get 5 amp hours of power out of it between the 20.8 and the 15 volts when it shuts down. So that's not too bad. Now, with my buck converter, I don't care about the voltage on all of these because the buck converter gives you constant voltage. This will drop down on this battery down to as low as 15 volts. Normally, if you didn't use a buck converter, if you just use resistors, your voltage here would also drop off. A lot of battery packs out there, they do that. They don't have a regulated power unit, a power outlet. So as the battery dropped down from its, like a 12 volt battery, might have 13.5 volts or whatever it is, depending on what type it is. When it drops off, when it gets down to 10.5, things kind of go wumpus. So you got to have a shutdown to shut it down when it gets down close to that. But your power drops off on your outlet from that 13.5 volts down to that 11 or 10.5 volts as you're using it. And that affects whatever it's plugged into. With this system, just like the Jackery that has a regulated 12 volt outlet, this will never have less than 13 volts in it. Always, constantly, when it's on. So, no matter the condition of the battery, you get a stable voltage out of everything else. That's important with some electronics. And so, that's one thing that makes this thing better than a lot of those things, a lot of those that are out there. Another thing. So, it's nice to have this extra port, but I put the voltmeter here because this is constant. I know it's going to be 13 volts always, but I do want to monitor the condition of the battery. Even though it has its own little light bar push, I don't have to touch that or do anything. I can see the volts instantly at all times, so I know when that thing's getting close to running or shutting down. So the way it works is I turned it on. I have 3 12 volt hook outlets on it. I have a 12 volt battery banana connector here. I have a 12 volt cigarette lighter plug in here. And over here I have my 12 volts plugged into 2 USB ports that give you 5 volts coming out, 2.1 amps. So to turn the power on these things, I turn this switch on and now I have power at these 3 outlets while this is on. When I'm done, if I'm not using any of these, I turn this off and there's no power drainage in here. The only power drainage is here on this voltmeter while this is in. Now, if I'm going to use 110 volts, I can do that too. I have this 2 plug in here, 200 watt inverter that I hardwired into the 12 volt system too. I cut the plug-in off of it. This is just one of those ones you buy that you plug into your cigarette lighter on your car and then you get 110 volts. That's all this is. And I cut the wire off and hardwired it in to the 12 volt side. So I now have 12 volts going into this. If I turn the power on, once it turns blue, now I have 110 volts there. So be careful, don't get shocked. I also have 4 USB ports here, 2.4 amps. So while I'm using this, I can plug my USB type stuff into here also. Just make sure that overall you stay under 200 watts when using this, or you'll break the circuit breaker on it. So while it's on, let me show you, it actually does work. So if I take my little fan here, which I have plugged into a power cord, and there's the other end. So we're going to take this and plug it in there, and we have a fan. Low speed, high speed, and no extension cord. This is great. I can carry this with me and go anywhere I want with this. So it actually works, and it works very well. Now, I didn't finish this thing as far as finishing it and closing it in because the buck converter has its own heat sinks. I don't know how hot that gets. So until I know how hot that gets, I don't know how much I can enclose this. But I can use it just like this, no problem. It just leans back like this, and I actually like this. I originally was thinking it would sit like this in a box. This would be the lid. But actually, I kind of like it sitting like this too. So depending on how hot that gets, whether I need an internal fan to enclose it completely, or maybe I can just put sides on it and then a plate on the back with holes in it. I don't know how I'm going to make it, but I'll make all that once I've been using it for a little bit to see how well it really works. So when not in use, you shut it off so it's not draining on your battery. And now my battery will sit there, and it could actually be sitting here for a very long time because the only thing it's running is this little jewel here, which I suspect only takes about 0.2 watts or something like that to run. It's very little. So this thing is actually very functional, works very well. I am very happy with it. To take the battery back out, you loosen that by a half a turn. Light went out. I can now pull this out. And now I can put it on the shelf until I'm ready to use it. Let's go over the wiring on the back so you can see how I wired it up. And a couple quick changes on the wiring diagram here to show you the changes that I made as recommended by you guys. First thing I did is I took the 2 fuses out, the small ones, the 5 amp ones I talked about, the one that goes to the meter and the one that goes to the USB port. These 2 fuses, I just eliminated them completely. They were right. The 1 fuse is all you really need. Now, they told me I should have that fuse up here by the battery. And again, they were absolutely right. I don't know. I had toyed with putting it there, and then I took it away, and then I put it back. So now it's going to be there. In fact, I did put it on there. I have 2 fuses on the system. And this is one of them. It's a 15 amp fuse coming right out of the positive of the battery. And after it comes out of the fuse, then it splits off to the meter and to the buck inverter. The buck inverter takes the power, positive and negative, and it goes to the buck converter on the inside, positive and negative. So there's 2 wire hookup. On the output, I adjusted that to 13 volts. So if I refer to this side here as 13 volt or 12 volt, that's what I'm talking about. Everything coming out of this converter then is only 12 volts, a constant. No matter what the charge of this battery is, until it shuts down, I will get a constant 13 volts on this side of the system. The ground, I just grounded everything together, again on the 12 volt side. I did put a 10 amp fuse on the output of the buck. And the reason I did that is that this particular buck converter, and most of them do have a fuse built in, but you got to watch out because those fuses are glass fuses and they're soldered in. They don't have a replaceable fuse as a general rule. And if you've ever had to change one of those, you know it can be a pain in the ass, intimidating for some of us. So rather than avoiding popping that fuse, I took and put a 10 amp fuse there. This is a 12 amp. I put a 10 amp there. So anything running off of the 12 volt side, it'll pop that 10 amp fuse before it pops the 12 amp fuse on the buck converter. That's why it has 2 fuses. This protects the whole system, and this protects the buck converter from anything on the 12 volt side. So that's the whole wiring in diagram with the changes I made. Let's show you real quick what it looks like. So in the world, this is what it looks like. I have my inverter here comes in and it hooks in on all the 12 volt wiring here. So everything over here and this one fuse, inline fuse here, which I can just open up, that's a 15 amp fuse here. And so what I did is I come off the positive of the battery and it goes into the fuse. It comes out of the fuse and the wires splits off to go to the meter and to the buck inverter. So 18 volts all right here, and it goes in at 18 volts after it goes through this. Coming out, all the grounds of all these other things are all grounded together, and they goes to the ground side of the 12 volt side, the output of the buck converter. The input comes out, the red wire, and goes into the other fuse. And this one is just a 10 amp fuse there. And there's 12 volts running through this fuse. There's 18 volts running through that fuse. So after it comes out of this fuse here, then it splits, then it goes up to the switch. And then whatever comes out of the switch is all split off to go to all 3 of these. The banana connector, the power outlet, and the USB port. All has 12 volts going to them. And that's how it all works. So that's the whole thing in a nutshell. I'm going to take these wires and hot glue them down so that they are not moving around or can rub against something hot or whatever eventually. But this thing is actually functional. It sets down and rests right on the back of these without any problem, so that I get a nice angle on this thing and I'll be able to plug things in. Once I get it enclosed, then I'll be able to set it this way or set it this way on a surface in order to use it, whichever is most comfortable for me. And how much I close it in will depend upon how hot this thing gets. So I do have to evaluate that before I go any further to make sure whether or not I have to actually vent this with a fan, or if I have to vent it a lot or just vent it just a tiny bit. We'll see. So one depends on how much heat. So that's how this whole thing works. Now I did take The plug-in to this, like I said, was just a cigarette lighter plug-in that you plug into your car. And I took and I connected 2 alligator clips to it. So now, if I want to just have 12 volts jumper, I have 12 volt jumper leads now that I can use. So I can use this thing for doing testing stuff in the shop and that too, if I want. Very convenient. So this is kind of a handy tool, and I haven't figured out where I can keep this thing yet. But that will be kept with this unit when I'm done. I'm sure it'll have some kind of nice little carrying handle on it. Like I said, it'll be boxed in so as to not expose all the wires. But how I do that will depend on a couple of things. So that's the whole thing in a nutshell. I hope I didn't take too long to show this to you. You can build this yourself if you want. I talk about previous videos how to make these things. If you want, just go to my playlist of portable power, and in that list, look for any videos that say power station in the title, and on those, somewhere in those, you'll hear about how these can be made. I'm going to go over that real quick in a 2-minute explanation before we're done here today, though. The buck converter. Let's talk about that real quick. On the buck converter, it puts out a constant voltage, whatever you set it to. But you have to be at least 1.5 volts less than what the battery is. So the battery starts at 20.8. It shuts off internally at 15 volts. So as long as I stay under that 13.5 volts, this battery will always supply power to that at 13.5 volts. It won't vary. Once it reaches that 15 volts and it drops below, now obviously this battery can't, but if your battery drops below that 15 volts, what happens is that then the voltage starts to drop off on the other side. So all of a sudden you don't have 13.5 volts, and as the battery continues to drop, you could drop to whatever that battery is in proportion. So the buck converter gives you that constant voltage instead. If I used resistors, then that drop off would occur as the battery dropped off. And these would not be a constant voltage, which is what I wanted. That's the big difference in why you want to use a converter instead of just use resistors. It's kind of handy. They're a little bit more money. I could do the resistors for pennies, but this is a much better system overall. As long as you be careful about your output of your buck converter to make sure that you don't overload it. That's the only thing. You have to make sure that you don't plug something in and draw more power than what this thing can put out. But the buck converter is the way to go. And if you want to put more batteries, I could hook up 4 batteries in parallel and run the system. In fact, I have one of those. If you read that power station, that is based on a 4 battery unit instead of this. And it runs off of 30 amps instead of 12 amps. For the circuitry. So it's a little different, a little more powerful, and I think I can run up to 800 watts off of that one if I remember right. But whatever it is, one of these days I'm going to go back and make a final product of that. When I do, then I'll show that one to you again. But that one is nice like this one. Now let me say real quick, if you're still with me, you can actually take this unit, and instead of plugging one battery in here, you could have a plug-in, like a cigarette lighter plug-in, and take this with the adapter, put on there and tighten it down, and you could hook 3, 4, 5, 6 batteries all up together onto one plug-in that then you plug that in as the power source. You could have that battery pack running this same unit easily, and it won't affect anything as long as these batteries are hooked up in parallel. That way, instead of getting 5 amp hours out of it, if you had 6 batteries set up as a battery pack, you would get 30 amp hours out of it. Now you're getting up there with what a regular battery gives you, an SL battery. There's a lot of 35 amp batteries out there. And with those, obviously, they're assets. So you only get half of the power, that you'll get out of these before it would shut down. So 2 70 amp hour batteries, 2 35 amp hour batteries is pretty close to what 7 of these batteries together will run the same power as 2 35 amp hour batteries. So it's easy to get a lot of power out of these. And if you use these batteries a lot, I carry 6 of these in the shop. I think I'm going to increase it to 10 or 12. And I try to keep them all at 5 amp hours at this point, since that's what I'm using. And if you're going to gang them together, you do want to keep them the same amp hour type battery to draw from. And make sure they're fully charged before you start using them as a battery source like that. If you plug this singly into here, I could take any size, any battery, and any rate of charge of the battery, how fully charged it is. If this thing was half charged only, I could still plug it in here and use it the same way. It just wouldn't last as long because the battery's already half gone. So when you gang batteries together, you get that same effect. As long as you parallel them, it just increases. But when you put them all together, they do draw on each other. So if one is only half charged and you put 2 together, one's half charged, the other one's fully charged, that fully charged one will drain down to bring them up to an equal level. And so you lose that battery power. So always make sure they're fully charged before you do it. Since we're rambling, if you're still with me, there's one more thing we need to talk about. And that is this adapter. Again, this is Ryobi specific. You have to, if you want to do another battery, I can't really help you because I've never worked with them, but I do know that they're all the same. Just you would have to have a different fitting. So let's talk about this here and being able to put this battery in there. Now, this particular unit right here is this one, and this is just a different color, but it has 3 tabs on it to hold it down to my plate. I cut the hole in the plate to fit the Ryobi battery and lined this up and screwed it down to hold it in place. Now it's beefed up right on the 2 sides where the terminals on the battery are, on the Ryobi battery, negative and positive. And when you put this in there, like so, and you have your 2 screws here, just like I did here, you screw that down, then they make contact, and now you have power, negative and power coming out of your battery. That's how you can connect your battery. And it would hold the battery in place when you tighten it down. Now, if you don't have a 3D printer or a good friend like George, like I do, this you may have a problem getting or finding. And that's okay. Because I also made this one. This is made out of 1.5 inch. It might be 1.25 inch, but I'm almost positive it's 1.5 inch PVC pipe. All I did is I took a 4-inch piece and I cut it out on the one end to give me these 2 tab areas here and here. And then I bent them over, and these are the tabs that hold this in place, just like these tabs hold this one in place. These 2 hold this one in place. And now this is held in. Then, before I mount it on the board, I heated this up with a heat gun, and I shoved it down on there and let it form around this. And then once it did that and cooled off, I took it off, I mounted it on here, and I put the battery, I put the battery in there. Like so. Now, then I lined up to where the screws would go to line up to those terminals, and I marked them, took it off, I drilled them out, tapped it, and put these screws in there with the terminals on them. Now when I take this and I put this on there, this screw set is already set to a predetermined place. I can take this one and I turn it a half a turn, and now it's locked down on there. This is not top. These are both now making contact because it pushes it into this one, and this one here pinches it, so that now you hook up a voltmeter here, you would read the voltage of this battery without any problem, or hook it up to some other machine, other type of stuff. So this is real easy to make out of PVC pipe if you don't have availability to have these. They both work the same. This one just doesn't look as pretty. But like I said, I used these at first for quite a while till George offered to help me with these. And they are nice. There's no doubt about it. And it does save me a lot of time making these things here overall. So again, thank you, George. If you want to know who George is, it's George Fernza. And his you can see his channel. If you go to my home channel on YouTube, he's one of the featured channels out there, George. So check out his channel, especially his early videos. He's got some awesome ideas on some of his early videos. He is well worth watching. So, I am rambling. So, anyway, that's the whole thing. If you have any questions, any comments, any ideas, any suggestions about future, because I think I'm going to do a daisy chain hookup to this so I can actually hook up a bunch of batteries to this thing if I want. I may just play with that so that I can hook this up to my computer and run it for 3 days off of a whole bunch of batteries hooked up together. So, and we'll see where that goes. If you have any questions or anything, like I said, leave them in the comments. I read them all. So, and I try to comment to 99% of them. If you like this video or you learned something here, hit that like button because that lets me know that I should keep doing some of these things. Most importantly, though, please come back again because I'm nowhere near done. Thanks, guys, and we'll see all of you again soon.